So in our study of mathematics so far, we have become very familiar with this thing, this little grid where we have the x-axis and the y-axis, and we've become familiar with plotting points like this, maybe 2 comma 3. We go over 2 and up 3. We get this point, okay? And we even gave these quadrants here names. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. Okay. So we've gotten a lot of experience with plotting points and graphing functions and that sort of thing in the plane with the with two axes, the x-axis and the y-axis. But imagine, of course, we live in a 3 dimensions. So you can see there would be applications beyond just what we can do in the plane. Imagine if you go right here to the origin and you have another axis coming out from that origin, coming out off the paper, off the board, and then going inside the board, where the axis coming out would be positive values. The axis going in would be negative values. And we'll call that axis the z-axis. So let's look at this. Let's look at a picture of what that might look like. Here's here's a couple of pictures. I just threw a couple in there. But notice if we do add that axis, so notice the way, and here's the convention we'll have. We'll call this coming out here the positive x-axis, going back here the negative. See the negative values. Here's x is -3, -4, and so forth. Over here is the y, where we have to the right is the positive y, to the left is the negative y. And we want to talk about, well, how do we plot points when we have the 3 dimensions? Well, we did have ordered pairs. Now we have ordered triples. See, we have the x, consider this point 2, -5, 3. We have x, y is the -5, and z is the 3. So we have the x, y, and the z. And if you look at that, how would we plot this point? Well, we go to the 2 on the x-axis right there. And then we go across until we lined up with the -5 on the y-axis, and then up 3 units. So we go 2, -5, and 3. Same thing over here. Like if we want to plot -2, 5, and 4. Well, this time we go -2 right there. We come over here to 5, and then up to 4. That's the way we plot those. Okay. Now, what we know about finding distance between 2 points, finding the midpoint between 2 points, all that still applies. For example, let's suppose I want to find the distance between these 2 points. I can still use the distance formula. So here it goes. The distance is equal to the square root of, let's see here, we've got -2 minus 2 squared plus 5 minus a -5 squared, and then plus 4 minus 3 squared, the square root of all that. So we still use the distance formula like usual. That still applies, only we have now another coordinate. Now, the midpoint formula also, I still reason the same way. If I want the midpoint between this point and this point, notice I just need to get the average of each coordinate. So I get the average of the x's, -2 plus 2 over 2, comma. Now I get 5 plus -5 over 2, and then 4 plus 3 over 2. I just get the average of each coordinate, and this is going to give me 0, 0, and 7/2. That's the midpoint between these 2 points. Okay. Now, here's the thing. If you go back and look at, let's go back to this thing. Remember, I said we have quadrants when we have a plane. Quadrant 1, 2, 3, and 4. Well, now if we add this third dimension, we don't talk about quadrants anymore. We talk about octants because there are now 8. So this thing right, so imagine this z-axis coming out of the board here. This thing right here, where you have positive x, positive y, and then positive z, that's going to be octant 1. Everything above this plane, okay? Everything above the Roman numeral 1, this is octant 1. Over here, octant 2. Everything above, all the z's are positive. Down here, octant 3 and octant 4. Okay, octant 1, 2, 3, and 4. All of those are just the positive z's that are above these quadrants. Now we want to talk about the other 4. If you go below this one, you start with octant 5, octant 6, octant 7, and octant 8 right there. Yeah. So now we talk about octants. So a lot of what you know about working in the plane, you can apply to working in 3 space. For example, on the plane, we work with circles a lot. So, maybe you've worked with problems like this: x squared plus y squared minus 2x plus 4y minus 4 equals 0. And you were asked, okay, identify the center of that circle and the radius. And remember, what we did was we would group the x's together and group the y's together. Let me make this, I meant for this to be 4y. Let me make that 4y plus 4y. And I moved everything else to the other side. Okay. And remember, we completed the square. We took half of the x term here, squared it, added it there. I need to add it over here as well. I took half of this. I got 2, square it, get 4, add it over here as well. And once we complete the square, remember, we can rewrite this as x and then this thing squared plus y and then this thing squared equals the other side. So here we get a circle centered at 1, -2. So the center is 1, -2, and the radius is 3. So it's of this form, it's x minus 8 squared plus y minus k squared equals r squared. And we completed the square and we got what we were, we identified easily the center and the radius. Well, you still can work that way. You can still do the same procedure, only now in space, you're not going to have a circle, you're going to have a sphere. So you're going to have an x and a y and a z. So you might have something that looks like this: x squared plus y squared plus z squared minus 2x plus 4y plus 2z minus 4 equals 0. See, so now you've got the z's in there. You proceed the exact same way as before. You group your x's together, group your y's together, group your z's together, and on the other side I've got 4. So then, you go through the same process. Plus 1, add a 1, plus 4, add a 4 over here, and then 1 and 1. So there you have it. Now all you do is rewrite it: x minus 1 squared plus y plus 2 squared plus, here's the new part, z plus 1 squared equals 8, 9, 10. So now we have a sphere this time, and the center is 1, -2, -1, and the radius is the square root of 10. So instead of a circle, just has the x and the y, we have x minus h squared plus y minus k squared. Oh, I ran out of let me do this. Let me do this. I did that out of force of habit. Let's call it x naught, y naught, and z naught equals r squared. Yeah, there we go. So the center is x naught, y naught, z naught, and the radius, of course, is r. So there is our sphere. So you can see things that we know about working in the plane a lot of times can generalize to working in the sphere. I mean, in the 3 dimensions.